The table below gives the retail sales in actual dollars for the last 14 quarters in New Zealand. So, and the goal of this exercise is to forecast the retail sales for the 4 quarters of 2001. So we have retail sales, the actual values given. For 1997, the last 2 quarters, September, December values are given. And for 1998, 1999, year 2000, the values are given for March, June, September, December quarters. And then we have the retail sales in actual dollars value in millions of dollars is given. Then we have some of the moving average values given, centered moving average given, and some rough seasonal values given. And we have a seasonal table, and some of the values are filled. That is for 1998 and the 1999 rough seasonal values are filled. And we have to find, we want to forecast the retail sales for the 4 quarters of 2001, for March, June, September, December of 2001. Questions? Graph this data. So let's plot a chart. So click in an empty cell, click on Insert, click on Chart, and let's carry this chart, move this to On Sheet. Click on Edit Chart. For the chart type, select the line chart, the straight lines. And for the data range, select the quarters. So we will select all the quarters, and we will select this up to December 2001 as well, and add another range that is for millions of dollars. And this is the graph produced. Let's do some customizing. So click on Customize. For the chart and Access title, for the chart title, type Retail Sales. And for the vertical axis title, type sales, and in bracket put millions of dollars. And for horizontal axis title, put quarters. And for the vertical axis, the grid axis, for the vertical axis, let's enter the minimum and maximum value. Let's enter 7,500. The minimum looks like we can have 9,000 maybe. And the maximum, we can have maybe 12,500. Let's have 13,000 because we have to plot the forecast as well later. And for the grid line and axis, grid line and ticks, For the vertical axis, the steps, let's select 500. And let's show the major ticks. And for the horizontal axis, let's show the major ticks. Let's show the data points. So click on series. For the point size, let's select 7px. And the line color, let's select black. Okay. So we have plotted the data. And what does this show? This shows that there is bit of stationary. We can see up to up to September 1998, and then it starts to the trend starts to rise. For 1999 and 2000, it starts to rise. Is it suitable for a multiplicative or additive model? So we can have additive model, and additive model is used. Let's label this chart as an additive model. Let's have line chart. Let's have line chart. Complete the calculation of the moving averages and the centered moving averages. So let's look at the calculation of the moving average. The moving average is for the 4 quarters, so 2 previous quarters, and the quarter for that location, and then 1 future quarter. So let's test those. Average of 2 previous quarters, 1 quarter, and 1 future quarter. Yes, so that looks all right. So the rest of the moving average will be equal to average of the previous 2 quarters and the value for that quarter and 1 future quarter. Close the bracket. This value, 1 feature quota is missing, so we can't have that. And so the moving average is up to September 2000. Now for centered moving average is the average of the moving average for that quarter and the 1 future moving average. So let's test those. Average of the moving average for that particular quarter and then one future quarter. Yes, that seems correct. So equal to average of that particular quarter and one future quarter. So we will have centered moving average up to June 2000. And then the rough seasonal value, let's test what is it, equal to the centered moving average value no, the observed value minus the centered moving average for that particular quarter. Yes, that seems correct. So let's fill the columns. Equal the observed value for that particular quarter minus the centered moving average of that particular quarter. Okay. And then let's fill these rough seasonal values. So we have found the moving average and the central moving average. Let's go back to the questions. Calculate the rest of the rough seasonals and copy them onto the seasonal table. So let's do that. So we have already found the rest of the rough seasonal values. Let's fill the table. So we have December 1998 and then March 99 the quarters of 1999. These values, and then the quarters of 2000. So we have two values for quarters of 2000, minus 1 for March and June. So we'll fill the table with that. And then we find the average of each quarter. So equal average of for March, and we'll find the rest of the values. Okay, so let's find the overall average. So equal average of all these averages that we found for each quarter. And then we find the adjusted values, and this will be the seasonal index. So let's find that. That equals the average for each quarter, it's an additive model we are using, minus the overall average. So for June, it will be the average for June minus overall average. For September, it will be the average for September minus overall average. For December, it will be the average of December minus overall average. So that's we have found those values. Now we will fill the seasonal index column with these values. So we have March, June, September, December. So for September 1997, it will be for September seasonal. And for December 1997, it will be December seasonal index. Then for 1998, for each of these quarters, March, June, September 1990, September and December, it will be the seasonal index that we found. Okay. So then from 1999, March, June, September, December, it will be the seasonal indexes that we found. Then for year 2000, the season March, June, September, December. So we'll copy the adjusted seasonal index. Then for 2001, we'll do the same. Okay. So now we find the deseasonalized values. So the deseasonalized values are the observed value. From the observed value, we will remove the seasonal index values. So we will subtract the seasonal index values. So we get, so the observed values were given up to December 2000. So we'll find the deseasonalized values up to there for up to December 2000. Complete the seasonal table to get the best estimates of the seasonal indices. Copy these seasonal indices as back up to the main table. We have done that. Graph the scented moving average on the original graph and extend this trend to obtain estimates of the trend for 2001. So let's do that. So on the graph, we want to add the data range for scented moving average. Okay, and then under series, we will click on add series and we will add CMA. And let's show the data points. Let's click on customize, click on series, double click on the scented moving average line, and we want to show the data points. So for the point size, select 7px. Now we want to extend this line up to December 2001. So let's have a look. So these values are given up to December. Scented moving average values are found up to June 2000. So for September 2000, let's take a value, say 11,000. Scented moving average for September 2000. Let's put the estimates in bold. Say 11,000. And for December 2000, say 11,200. Say 11,300. And for March 2001, it's an increasing trend. So let's say 11,500. And for June 2001, let's say 11,700. And for September 2001, let's say 11,000, say 900. And for December 2001, that will be higher. So let's say it's higher, say 12,500. For September, actually we have the seasonal index value. September 2000, we have seasonal index value, and we have the observed value. So uh, okay. Now, what happens is that these are the estimated centered moving average values. Now, to find the forecast so we have estimated the values. Let's go back to the question. So we have obtained estimates of the trend for 2000. The choice of extending the trend will be slightly different for everyone, so the forecast will differ slightly. Use these estimates of trend together with the seasonal indices to calculate forecast of the 4 quarters of 2001. So this so the observed value minus the uh, central moving average will give us the rough seasonal values. And we have the seasonal index value given for each of these quarters. So what we will do, we will add the seasonal index values to the central moving average values to get the observed values. Now this so the central moving average for September 2000 was added to its seasonal index value to give 10,607.4. So if I subtract the given observed value for September 2000, if I take that and subtract the seasonal index value for that quarter, that will give me uh, the centered moving average for that particular quarter. And same for December 2000. So equal the observed value for December 2000 minus the seasonal index value. Okay, so those two values could have been calculated easily. We will unbold that one, those two values. Now, the forecast. So the observed value minus the seasonal index value for that quarter equal the estimated central moving average value. So the central moving average value added to the seasonal index value will give me the observed value. So equal the central moving average plus the seasonal index value. Okay, so let's look at the line chart. So we have forecasted. Let's edit the chart and let's go to customize. Click on series. Now let's select this bullet point from March, June, September to December. Let's color that differently. Let's say color that dark green, and let's have the point size little bigger. Let's have it to 10px. Same for June. Color that green. Let's have the size as 10px. And for September, let's color that green and let's have the point size as 10px. And let's extend the vertical axis. So click on vertical axis, maximum. Let's type 13,200. Say 13,400. Say 13,500. Okay, and let's color that bullet point differently. Okay, so this is the forecast for March, June, September, December. Use the seasonal indices to deseasonalize the original data. So we have already deseasonalized. Let's plot the deseasonalized data. So add the series, add another data range, and that's for deseasonalized column. And let's add that series. Okay, let's we have the deseasonalized values up to December 2000. So that was observed value minus the seasonal index. So let's find for the forecast as well. Okay, so questions. Is the central moving average or the deseasonalized values a better estimate of the trend? Explain your choice. The deseasonalized values contain irregular variation, which is largely smoothed out in the central moving average. So the central moving average will be a better estimate of the trend.